So I got a pretty straightforward idea. I guess Celeste gave me this idea inadvertently. She used to work for a logging company for a short while, and it gave me an idea of how to explain how stars evolve. In light of somebody telling me earlier today saying, well, they can't actually observe a star transforming into a planet. It's never been observed. That's not the point. It can be inferred. Using this theory, you infer the stage of the star, the stage of evolution a star is in. You don't have to sit there and watch it evolving in order for it to be true. That's ridiculous. For instance, you have plants. In the logging industry, believe it or not, the wood that you have in your house started like that. It's a little seed. And the seed grows and grows and grows. And eventually it becomes a sapling, which continues growing and growing and growing. And then the loggers come around and chop it off, and this is a dead tree. You just have the roots and the stump left over. But you wouldn't sit there and stare at a tree and say, well, clearly we don't know if these little round seeds become this, because we've never seen it happening. Of course, you can't watch it happening, watching a tree grow. No. You can infer that it grows from that by looking at different stages of growth that it's in. You don't sit there and say, well, I can't see it growing, therefore I don't know if it's ever happened. That's ridiculous. And I just wanted to clarify that, because I hear that sometimes, and I'm like, you don't have to visibly see in our time frame something occurring for yourself to be able to deduce or infer what's happening. Same thing with people. You have newborns. Of course, before this, you have the baby growing in the womb, and that's really cool, from embryo, fetus, and all that stuff. That's really, really cool stuff. 0 to 3 months, 4 to 11 months. Notice how they skip 11 to 3 years, 11 months to 3 years. And they skip a year there. 13, 14, you skip a year there. 18 to 25, so 18 to 25, you know, there's a 7-year gap of partying. I guess they don't want to talk about that. 25 to 45, 45 to 65, 65 to 70, there's the just getting a lot of retirement money and blowing it stage, I guess they don't want to talk about either. And then you got your 70 to 90 years, and obviously you can infer how old somebody is by looking at them, by observing them, by measuring their bone density if they have beginning osteoporosis, by measuring their injection fraction of their heart to see how well their heart pumps blood. An injection fraction that's really low is probably an older person. You can infer from the enamel in their teeth when you do autopsies for somebody who had died. You can determine how old somebody is by their teeth, I believe. I can't remember how they do that. There's other ways you can infer what stage of growth and decay a human being is in just by looking at them. But if you look at me at being 35 years old, you say, well, clearly I can't see you growing, therefore I don't know if you're going to become an old man or not. What? As well, I can't see you growing, and I can't see the previous stages, so I can't know if you were a baby or not, if you were an embryo. Nobody would ever say that. We can infer it directly from our observations, because there are human beings in those different stages that we see. We know it happens. And that being said, for the money's worth, people, Baz made one diagram, I cut it up and put it side by side. It's okay, so you have the babies, you know, left to right, babies, and you have this, stellar babies. You have the white dwarfs, which expand outwards, becoming large blue stars. Then they start dimming to yellow, to orange, to red, to brown dwarfs, to Jupiters, gray dwarfs, Neptunes, ocean worlds, Earths, Venuses, and Mercuries. And this is a dead star. This is a tree stump, just like in this one. At the very end, right there, or wait, right there, at the very bottom. That's a Mercury. It's a dead star. It's wandering around the sun, and astronomers are like, oh, it's a planet. We don't know how it formed. We don't know how it got its large iron nickel core. Dude, it's a dead Earth, and Earth is a highly evolved Neptune, and Neptune is a highly evolved Jupiter, and Jupiter is a highly evolved sun. They're all different stages of stellar evolution. They're all essentially the same thing. Just as human beings are the same thing, even though they're labeled as babies or embryos. Just as seeds are the same things as trees. Sure, they're not exactly the same thing, but their DNA matches. I guarantee you take the DNA of a seed, you can match it up with a fully grown sequoia tree. It's the same thing. It's going to become something different that appears different on its face, but we all know better. So every time I see that, and if anybody else is to come across that saying, we can't see a star becoming something like the Earth, of course you can't watch it doing that. It's like the old saying, you know, watching paint dry or watching water boil. It just takes a long time for it to occur. But I mean, we can watch water boil. I wouldn't want to do it. And you can watch paint dry, you know, happens within 24 hours or so. But to watch something like the sun become something like Jupiter would take hundreds of millions of years. Of course you can't see it happening in real time. And to expect it happening in real time, I don't think that's a good way of looking at anything in nature. If that were true, then bam, everything should just have formed in 6,000 years just as it is. Everything took, you know, no time at all to form. Even 6,000 years is a long time. Unless you're under the mentality that everything just clicked into existence like the people who believe Big Bang happened. They just want everything to click into existence. But on its face, it's just ridiculous to believe anything like that. It takes a lot of time for things to occur in nature. It just doesn't happen overnight or within a few seconds. I mean, there are a few things happen in a few seconds, like a lightning bolt, but still, there are scales of time. And to put your mind into that, to realize that the large structures in the universe, they're really big stuff. It takes time for it to form. That's why the Earth is 4.5 billion years old. It took a lot of time for the Earth to go from way over here to all the way down here. And there's an ocean world, a Neptune, a gray dwarf, a Jupiter. It takes a hell of a lot of time for stars to evolve. And I guess this is lost upon astronomers because they don't look at the stars as being evolutionary structures in essence. They just look at them as, oh, when they get old, they explode. Or when they get old, they collapse into a black hole. They don't actually look at them as evolutionary structures, even though they say, oh, it's stellar evolution. They don't believe in evolutionary structures. Anyways, I think I summed this up for you guys. Hopefully, the point is a lot clearer than what it used to be. Later.